Hello everyone. So in this video, we will be learning about the third solid principle, which is Liskov Substitution Principle. It is a very scary one. No, not really. It's not that scary, but very, very simple. So let's just get started with it. So what is the definition of Liskov Substitution Principle, first of all? It says that any instance of a subclass should be substitutable for an instance of its base class. So simply put, the subclass should behave in such a fashion that is consistent with the base class. Well, I'm pretty sure you found that confusing, and I'm pretty sure you didn't get anything from it. So let me take a very simple example to demonstrate that before you guys run away from this video. So let's just go ahead and make some changes to our vehicle class here. We'll also have an abstract method. Let's call it refuel and then pass. Now we'll go on to copy this and implement in both of our car, and we'll make some changes here. Let's say I want to print refueling the car with petrol. Similarly, I'll copy this and then paste it to our truck. Just paste it here and we'll change this to diesel. But wait, did I just break the open-close principle here? Looks like in the vehicle class, I added a new method called as refuel, and looks like we have broken the open-close principle. Well, not really. So this is because we are not modifying the internal code inside any of the pre-existing methods to add new features. Instead, we are adding a new method, and that doesn't alter any existing functionality. So we are good. We are not breaking open-close principle here. Now let's say we want to add another class here. Let's say we want to have electric car, and then for that we'll have from vehicle, and then I'll implement the whole class here. Let's just get rid of all of this. I think we'll define the calculate insurance cost as, let's say I go ahead and use this logic here. I calculate the age as 2024 myself here, and let's just change these numbers to 2000 and 1000. Wonderful. Now similarly, let's go ahead and make changes to this refuel method here. Since electric cars do not have the refueling, they charge via electricity. What I'll do, I'll raise an exception here saying that electric cars cannot be refueled. Let's start with that. Now after that change, let's just move ahead to our main class and then make changes here. So first of all, I'd like to import the electric car from electric car. That looks correct. And then for this part, what I'm trying to do is have an electric car. Okay, that looks correct. Now I'll have a vehicles list which will contain all of these. That looks correct as well. Now I'll have a loop for vehicle in vehicles just to a refuel. So let's just go ahead and run this. Let me see. I think there is some issue here. Oh, it says electric cars cannot be refueled. Both of those, car and truck, I think those went well. I think refueling the car with petrol and refueling the car with diesel, that looks correct. But what about this, the electric car? I think that is showing an exception. Well, that was expected, right? So now we see a runtime exception here because our subclass in this case, electric car, is implementing some of the methods, but not all from vehicle. So it was implementing calculate insurance cost correctly, but not refuel. It was throwing an exception there, right? So we broke the Liskov substitution principle here. Electric car is not consistent with its base class, which is vehicle, and it should have a refuel method which doesn't throw exception, rather print something, very similar to all the other classes like car, truck. So don't you think it's a very intuitive principle? Whenever writing a class, you should always be consistent with your parent or base class and implement all the methods in it, right? So it's very, very intuitive principle. So in general, let's say there were 10 methods in base class in this vehicle.py, and your new class only implements 8 of them. For 2 of them, it simply throws exception. That would again violate Liskov substitution principle. But now, one very natural question comes to everybody's mind is that we will run into these kinds of ugly situations very, very often, where we can't implement all of the methods from our base or parent class. So what could be done here? Well, for that, we will see how we can solve that using the insolid principle, which is interface segregation principle. Not in this video, but the next one. So for now, let's just get rid of our electric car class itself. Let's just fix that. And in our main method, we'll have to make some changes. We'll have to remove this and also this part and this one. I think now it should probably run. Okay, so it looks correct now with diesel, the insurance cost and the printing. That looks correct. Now we all know that we should implement all the methods from its base or parent class. That's what we saw here. But there is one more thing to remember in Liskov substitution principle. We need to be consistent too. Well, wait. What does that being consistent mean? Didn't it mean that we need to implement all the methods? So let's just understand this using another example. So let's just go into our truck class and let's say we make some changes here. We say when we calculate the age, we'll add one more condition here. If age is greater than 20, let's say, we'll return none instead of a numerical. Now let's go ahead to our main method and try to run this. This looks good according to me. But what if I change some things here? Let's say I change this to 1990 or let's say 1980. And I also go ahead and add 100 to both of those and try to run this. Oops, looks like we are having some runtime issues here. So when we do that, we have changed the logic in such a fashion in truck that the age, if it's greater than 20, will return none. And we can't add none to 100. And that is where everything goes topsy-turvy. But that wasn't the case with car. We didn't make any such changes in that. All of the returns from this method are numerical. So there was no issue with that. Here again, we broke our Liskov substitution principle when we made our changes here. Here, we were returning none sometimes and sometimes numerical. But that wasn't the contract that was present in vehicle. This whole method was implemented in such a fashion that it would return numerical. That was being followed in car here, but not in truck. So that is what Liskov substitution principle says. We need to be consistent with our parent or base class. So let's just go ahead and get rid of this part here. And let's just try to run this again. And now it works perfectly. So let's just summarize what all we have learned today. The first point is, in order to follow Liskov substitution principle, each class needs to implement all the methods from its base or parent class, that is both of those without any exceptions. The second thing is, each method implementation should be consistent with the base or parent class. In our truck case, we saw that we were returning none sometimes numerical values. That was inconsistent with what vehicle had. So in order to follow Liskov substitution principle, we don't need both of those. We need to implement all of the methods from its base class, and we also need to implement in such a fashion that it's consistent. Now we can say that we have understood Liskov substitution principle. But again, we have the same question again and again. Why are we even learning this? What happens if we don't follow this Liskov substitution principle? So let's just go ahead and understand that here. So what happens if we don't follow Liskov substitution principle? Well, we have already seen the consequences here. So if we don't follow this principle and then create subclasses, like let's say electric car, or we made changes to the truck which were inconsistent with the parent class, that could lead to unexpected runtime issues. That's what we have seen here in the case of truck and case of the electric car here. So we'll see errors or incorrect results. So what is the summary? What should we as developers remember? So, well, there are two thumb rules here, or pointers that you should understand, which are basically the Liskov substitution principle. So the first thing you need to remember is that whenever you create a new class, make sure to implement all the methods from its parent or base class. Very intuitive, right? The second one is whenever you are creating a new class, make sure to have it consistent with the base parent class, especially the return value. That's what we saw in the truck case. So that's it for this video. Hope to see you in the next one where we'll be learning about interface segregation. Pretty exciting, right? So see you in the next one.